going to go ahead and just start with number 2, but the first part is deciding whether it's growth or decay. And remember, that's all about the base of the power, right? So looking at the 4, looking at the 3/5, that's how you can tell if it's growth or decay. And growth comes from things that are bigger than 1, and decay comes from things that are less than 1. It's not a negative issue; it's a fraction issue, right? A decimal, something you have a fraction of what you had previously. That's what makes it decrease or decay. Okay, so just starting off there, that's going to be a decay function. We have the little t-chart over there. That's the kind of the minimum that you guys need to do is these 3 numbers. Okay, you can see on the subsequent problems I did not put the t-chart there, but that's the expectation as you guys are doing this. So basically just plugging in those numbers in. 3/5 to the 0 power, 3/5 to the first power, 3/5 to the -1 power. And for most part, it should be pretty straightforward. 3/5 to the first power is just 3/5. If you're not sure what that's equal to as a decimal, though, because decimals are easier to graph, that is 0.6. Anything to the 0 power is 1. And then negative exponents on fractions, those flip to fractions. So it's not 3/5 anymore, it's 5/3. Okay, but what's 5/3 equal to as you go to graph that? So if you need to put that in a calculator to graph it, what's 5? It's going to be like 1.66666, so essentially 1.7. Okay? So I'm going to plot those 3 points. 0, 1, 1.6, -1, 1.7. That's not a lot of information there. Okay? So do I need more points? Do I want more points? So at the very minimum, you guys need those 3 points. If you feel like you need more points to help you draw the picture, then get more points. Okay? That's up to you. Really where you should be looking on this problem to get more points is on that left side, because things are growing on that left side. Where does that curve go? You should know where that curve is going on the right side, because that big key feature of these functions, that new word, that asymptote. For exponential functions, the asymptote is supposed to be at 0. So at the very minimum, I expect you guys to label that. Y equals 0 should be labeled. Since it is on the axis, I didn't ask you guys to necessarily draw it, because it is kind of difficult to see with a pencil. Okay? But at the very minimum, you need to have that labeled. So on that right side, we know the graph is just going to keep getting closer and closer there. So maybe I don't need more points. But maybe I'm curious, like, where do I draw this curve on the left side? So maybe I want to get more points. So I plug in -2. So what's 3/5 to the -2? Well, the negative flips it, and then the 2 squares it. So I get 25/9, which when you put that in a calculator turns out to be like 2.7777, so it's about 2.8. Okay, is that enough information now? All right, now I'm here. I don't know, it's up to you. All right, again, this part really is: do you want more points? Okay, you have to have the 3. Do you want more? And maybe you feel like another one would be helpful. So the negative flips it, and the 3 cubes it. So 5 cubed is 125. 3 cubed is 27. What's 125 divided by 7? 125 divided by 27, 4.6. Okay. Now do you feel comfortable having enough points to get that graph drawn? Okay. Kind of leave that up to you guys. You need at least 3. If you want more, get more. So on that right side, what I ask you guys to do is kind of run parallel to that asymptote. Okay. And then you curve up through those points. Oops. Arrows on both ends. Okay. Make sure on that right side that it doesn't go down below the asymptote. Make sure it doesn't bell back up. Okay. It should run parallel to that asymptote. Remember, the idea is that it is getting closer and closer and closer. That's really hard to draw. Okay, so I asked you guys just to run it kind of parallel to it. All right. Domain and range should be easy peasy, or domain should be easy peasy because it's always all real numbers. Okay. Range, your lowest to your highest. So this is an area where I've seen mistakes. The lowest value is going to get closer and closer to 0, right? It's that asymptote number. So the asymptote's at 0, so it's going to get closer and closer to 0. Then it's going to go up forever. Okay. What I've noticed some of you guys doing is mixing these numbers up, especially if the graph was reflected and it looks something like this. It's going down forever, then it's getting closer and closer to 0. So I've seen some stuff like this. Okay, that's not okay. This is always the small number. This is always the big number. When you're doing interval notation, it always goes from small to large. Negative infinity is smaller than 0. That would be negative infinity to 0 would be the appropriate way to write that. Okay, so I've just seen some people putting things in the wrong order. Okay? So go back and look at your graphing assignments you turned in. Did you get your ranges right? I don't remember what class it was, but there was somebody that was definitely messing up the ranges like hardcore. I was marking them all out. Okay. Domain should be easy. Got to watch that range a little bit with these. Okay. Make sure you go from small to large. Jacob, do you want to do number 3 and then number 6 are essentially the same? You want to do 3 or 6? 6, okay. So 3 and 6 are very similar. Why I'm saying that is because they both have shifts in them. Okay. So I'm looking at these, all right, the shifts left and right and up and down versus like a reflection or stretch, compression that we're seeing on 5, 7, 4. Okay. So the first thing I want to look at is whether it's growth or decay. So what I want to look at is that base of the power. So just that. That number is bigger than 1, so that means it's growth. Okay. It's a growth function. And as you guys go to set up your table, little t-chart, you're going to use the base function. Okay. So I taught you guys how to do this the other day. 5 over 2 to the x. I'm going to use the base function. To set up your table. So 5 halves to the x power. And we start there. We have our 3 numbers, -1, 0, and 1. 5 halves to the 1, 5 halves to the 0, 5 halves to the -1. Shouldn't need a calculator for this, because 5 halves to the first power is 5 halves. All 5 divided by 2 is 2.5. Anything to 0 power is 1. And negative exponents on fractions, flip those fractions, so we end up with 2 over 5. 1/5 is equal to 0.2, 2/5 is equal to 0.4. So there's my 3 points. 1, 2.5, 0, 1. -1.4. Okay. Remember, the asymptote is supposed to be at 0, right? That's going to change. It's supposed to be here. Okay. Not going to change yet, but it's going to change. So what else is happening? Now I go and I look at those transformations. Up there in the exponent, in the function, is our left and our rights. Our left and right guys are a liar. So that says -2. That's going to be a right 2. So I'm literally going to take all of those points and just move them right 2. 1, 2, point. 1, 2, point. 1, 2, point. Okay? But I don't want those little seagulls there. I'll get rid of those. Okay? So move them right 2. And that -3, that's going to be down 3. So you literally take each of those points and move it down 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. Okay. And in the same way, the asymptote is also going to drop 3. So the shifts up and down, they're your big effectors. Okay? They have an effect on the asymptote. As we take a horizontal line, move it up, move it down. Okay? Can't move a horizontal line sideways. Okay? We can move it up and down. So our asymptote was shifted down. So as I go to draw my curve, on that left side, it's going to scoot along that asymptote parallel, and then curve up through those 3 points. Steep curve on that right side. We said it was a growth function, right? Does our graph look like a growth function? It's going up, right? That's good. That matches. If you write growth here and then your graph is going down, that's a problem. Okay? Better be going up to the right. So there's our graph. I don't know why DYM means, Peyton. Domain, always all real numbers. That never changes. That should be easy peasy. All right, where does this graph go? The lowest value it's going to get close to is -3. So here's that down 3 having an effect again, -3. But then it goes up forever. Okay. So what did that down 3 do? Changed our asymptote and changed our range. So shifts up and down have effects. We've got to watch out for those. Okay. Asymptote's always the point that the graph is going to get close to, right? It's never actually going to reach -3, but it's going to get really close, right? Yep. So with those shifts, I want you guys to start with that base function and just move the points. I don't want you guys messing with the tables at all, okay? There is a way to do that. It's not something I've shown you guys because it's just too confusing most of the time. It's something I tried teaching in the past and just didn't go over well. So just literally move the points. It's much simpler to do that. Okay? We'll get there, Peyton, when we get to those examples in class. Anything about number 6 you guys want to talk about? Oh, because the asymptote is not on the axis, I do expect you guys to draw it. Okay? So label it and draw it. It needs to be drawn, not just labeled. So the asymptote is there visually for us. That's why it's a dashed line, because we draw it so we can see it. Okay? So it needs to be drawn to be seen. If it's on the axis, I don't expect you guys to do that. Okay? No, number -3 is not a bracket because we did not hit -3. There was no number we could ever plug in that would give us -3 as an answer. It'd only get close to -3, Peyton. All right, that's why we draw it like this on that left side, because it's not going to hit -3. Make sense? Lucas, you want to do 4 or 5 or 7? 5? Yep. How would I know? So first thing I want to do is decide if this is a growth or decay function. So Lucas, do you remember what E is equal to about? Yep. So E is about 2.7, right? Remember, E is a number. It's not a variable. It's about 2.72 some. Okay. Of course, 2.7 is bigger than 1, so this will be a growth function. Okay. So the half is causing a compression or a shrink. So it's just going to grow slower than it normally would. Okay. But it's just still going to grow. So what I want you guys again to do is start off with that base function. So our base function is e to the x. Not doing the half, I'm just doing e to the x. So e to the 0, e to the 1, e to the negative 1. No, anything to the 0 power is 1. Just said that e was equal to 2.7. So, and then what's e to the negative 1? I remember, but only because I've done it so many times. So e caret negative 1. Yeah, it's about 0.4. Okay. So a little bit less than half. So do your best there. 2.7 should be about there. So there's our 3 points. Okay. The asymptote is supposed to be at 0. Right? Is it going to stay there? Right? Last time it moved on us. Well, what's happening here? Vertical compression, a vertical shrink. Okay, that's not a shift up or down. So that means our asymptote will stay at 0. So if you need to write that, then write that. Okay, so there's no shift up or down, so there's no change in the asymptote. Right, so it's staying put at 0. That's where it's supposed to be. Only thing we can do to it is shift it up or down. Okay, this one's not shifting up or down, so it's not changing. So what is changing? So I did show you guys on this what's kind of easy to do because it's a compression or a stretch or a reflection. You can take that and you can do this. You don't have to. I can multiply that by a half. I can multiply that by a half. I can multiply that by a half. You don't have to do this, but you can. It's pretty easy. So half of 0.4 is 0.2. Half of 1, of course, is a half. Half of 2.7 would be like 1.35, about 1.4. Okay? We can't tell the difference between 1.35 and 1.4. We can't graph that closely. Okay? But the idea is that each of those points should be half as far away from the x-axis as it started off. Okay? So this is the easiest one to see. If this is 1 unit away, then it should be half that distance now. Of course, half would just be half. If it's 2.7 units away, then it should be about 1.35 units away, half of what it was. This distance is half of that distance. And then 0.4 and 0.2 are right on top of each other. Okay? So there's my transformed points. Still have my same asymptote. So on that left side, I'm going to kind of scoot along that asymptote, and then I'm going to curve up through those 3 green points. It's just going to be a flatter curve than the red one would have been. The compression is squishing it down. Okay. Left side, flat along that asymptote. Oops. Curve up through those 3 points. Just, what do we know about exponential curves? They take off pretty quick. Even if they are compressed, they still shoot up pretty quick. Okay. So and I don't really know where it's going, but I know it's heading off to the right, up pretty fast. Domain, no reason you should miss that. It's all real numbers. Right, you can plug in any number you want. Range, where's your asymptote? Starts at 0 and goes up forever. Okay. So since we didn't have any shift up or down, the 0 didn't change. Okay. Again, there's 7 graphs there. You guys are going to do 2 on the test, and the other one's there for extra practice if you need it. Okay, especially if you didn't do that assignment, or if you did poorly on that assignment, the extra practice is going to be good for you. Okay, so judge that. If you understood the graphs, you probably still understand the graphs. Okay. I can tell you the asymptote issue and then the range was definitely the most mistakes. And people just struggling to get these calculations done. Not doing this well, the fractions especially. Some bad calculator work. 8 through 11, these really should be like the easiest problems for you guys because we've done this so many times. The main mistake I saw was you guys getting a little confused like with the 2 here on number 8 or like the 2/3 versus the 1/2 on the 9. Again, just want to focus on that idea that there's a base function. 2 to the x is the base function. I don't need to talk about the 2 to the x. What I need to talk about is the things that are new, so the negative and the -5. I need to talk about those things. Same thing over here on 9. The 2/3 to the x is the base function. I don't need to talk about that. Okay. What I need to talk about is the 1/2 and the 1. Okay, that's what I need to talk about. Remember with these problems, y equals a times b to the x minus h plus k. That's our general form. A can be our vertical compressions or stretches. I think by far, something I'm not seeing a lot of that I've been asking you guys to do, make sure you're paying attention to, is that you're writing by a factor of. So even after I brought that up during that lesson, still some people weren't doing that. So if I say it's being stretched by a factor of 2, not stretched by 2 units, okay, by a factor of. So I do look for that language. You guys do lose points if you're not using that language when you're writing them. The other side of that could be reflections. So it's either a vertical reflection or it's a reflection of the x-axis. You guys do need to be specific because there are other types of reflections. We haven't done them, but they do exist, so you do have to be specific in your language. A reflection over the x-axis. That's what A can do. Remember, H is your shifts left and right, but it's a liar. I do expect to see that verb there. It's not just left 2 units, it's a shift left 2 units. You need to have a verb, okay? Or it's a move left 2 units. H is our liar. We use the word units. We talk about shifting. And then K is our shift up and down. That one we trust. Again, you use the term units when you talk about up and down shifts. This is like the 4th, 5th time we've talked about this. You guys really should be good at this by now. So looking at number 8, I notice there's a negative on it. I notice there's a -5 on it. That negative is my reflection. So I'll say a vertical reflection, or I could say a reflection of the x-axis. And -5, it's up in the exponent, okay? The exponent versus the being after, like the 7, the 2 versus the 7. So the 5 is up in the exponent, that's the h spot. And h lies to me, it says -5. That's going to be a shift right 5 units. So again, the verb there, I've seen a lot of people dropping that off. The little kind of notation there at the end was saying units. That needs to be there. Type of reflection. Nope, no lesson today, Brooklyn. Nine. So that half is less than 1. So that's a vertical compression or vertical shrink. And again, by a factor of. When we say by a factor of, that means we're applying multiplication, because the half is multiplying the problem. So vertical compression by a factor of 1/2. And then again, the 1 is up there in the exponent. That's my left and right. It's a liar. So that's a shift left 1 unit. Okay. And those would be ones generally you guys would like type those out for me. We've done those quite a bit. Anything 8, 9 you guys got a question about? Okay. So we got the word problems here. I should say 17, shouldn't it? So, big thing, again, you guys is going to be reading, okay? Which function is which, or which formula goes for which? Okay, what's the key word in there that's going to be telling you to use the red formula versus the purple formula versus the green formula? Okay, so as you're reading the problem, what do you look for that lets you know that? Okay, usually it's just one word that'll let you know that. So, look at the purple one and the red one. They're essentially the same, right? One has a plus, one has a minus. Plus one was the growth function, the minus was the decay function. What types of words do we see for growth? Well, you might see grow, right? You might see increase. I don't know, there's really too many other words. Yeah, I don't know. I think about growing, that's what I would think about, okay? The purple one was the decay function. What type of words would we use? We don't usually use the word decay very much in normal life. What type of words would we use for decay? Well, like decrease instead of decline. You had a population that was in decline. Right? There are a lot of deck words, right? Decay, right? Like all those words start with dec, right? So that would be an indication that's the function you should, or the formula you should be using. That middle one, that was the different one. That was our compound interest. So really, as soon as you see that word compound, when I write compound interest, but as soon as you see that word compound, pretty much lets you know that that's the one you should be using. Okay. So as I look through the problems, just real quickly, okay. Powerful computer is purchased for $2,000, but loses 20%. Ooh, there's a word, right? It's not one of those words, but pretty connected. Loses 20% of its value. Okay, so that's a decay or problem. Initial population of 450 endangered turtles is growing at a rate of 15% per year. Okay, that must be an exponential growth problem. $5,500 is deposited in a savings account, earning 5.4 interest over 7 years. Write a general equation, exponential final. Oh, there's that compounded word. It took me a while to find it, but there it was. How do I know which formula to use? So make sure you're looking through those for that word, right? Where is it? And letting you know that. Another big thing that, again, I asked you guys to do when we were doing the notes, still some of you guys struggled to get it done, is that you're writing a model equation or a general equation. So I try to be a little bit more explicit here that, like, step A, don't skip step A, write the general equation for the model, right? And so when you write a model equation, that's going to have a variable in it still. Okay? For the growth and the decay functions, that variable is t, because we find out t later. We find out the time later. We start off with our initial amount and our rate. We end up with t later. Okay? So if I want to write this equation for number 12 here, I need that a value, which is my initial amount, and then that rate. Remember, the rate comes back at us as a decimal. So 20% as a decimal, 0.20. Okay? And this by far is one of the areas that most common mistake is people not writing their rates correctly. So if I want to write this model equation, let's say this is a declined one, so I don't know why I'm doing it in red. I should be doing purple. Dang it. So y equals 2,000 times 1 minus 0.20, or you can just write 0.2 if you want. But then it's a model because it still has t in it. This is your model equation. This is your general equation. I do expect to see these on the test. You're going to write a model or a general equation first. Then you're going to go and find out the value or values that I'm asking. Does that make sense, Peyton? So then I would go and say, hey, what about B? Right? 2 years. Now its t is 2. So y equals 2,000, 1 minus 0.20 to the 2. All right, so now I've plugged in that value. Okay? You guys really aren't doing much math here. That's going to go in your calculator. Okay? It's all about the reading, picking things out, getting the decimal change to a rate change to a decimal properly. But you're not doing a lot of math. Okay? Focusing on the reading and the writing. I've seen some students like doing this in pieces. Like they go and they do this math, and then they do this, and then they multiply by that. Really, I would ask you guys not to do that. Okay? Type it all in your calculator at one time. Because the more times you interact with your calculators, the more chances you're going to mistype something. That's definitely a super easy mistake. It's just to mistype something. Okay? And there's really no way around that. You can't see it because you could write down the right thing and then get the completely wrong answer because you just mistyped. So the less interactions with your calculator, the better. Okay? So 2,000 parentheses 1 minus 0.2 parentheses caret 2. So right now I should stop and check. Does that look okay? But then when I hit enter, any good scientific graphing calculator should give you a display like over there on the left. You look at that and say, does that look like what I wrote? The way it types and the way you wrote it need to match. Okay? Does my answer make sense also? The computer was supposed to decrease in value. Do I have a smaller number than I started with? Because how easy would it be to do this, accidentally type plus, or think that it was a plus, and then you have a higher number. Like, that didn't lose value. That shouldn't make sense. Okay? So does your answer make sense? So the money went down, the value went down, like it said it should. And what are we talking about here? Right? We're talking about money. We're talking about the value of something. Well, how do we talk about money? So I'm asking you guys to use appropriate rounding and appropriate units. But that changes based on what the problem is about. This is about money, so I better have a dollar sign. And how do we talk about money? Well, money has cents. So even though that came out to be an even number, that's how we would write it. 1,280 and 0 cents. Okay? So appropriate rounding and units. I'm expecting those to be there. Okay? And when you look at the next problem, which is about turtles, you have a different type of rounding, and you have different units. That's why I'm saying the word appropriate. What's appropriate for this subject? For money, the appropriate thing to do is 2 decimal places and a dollar sign. Okay? So then you would find C and D also. Okay? Look at 13. That's a growing problem, so I should be using the red formula, the plus in it. I need my A value and I need my R value for the model. My A value, the initial amount of turtles. R value, which is the rate, but we always write that rate as a decimal. 15% is 0.15. So my model, y equals the initial amount of turtles times 1 plus, make sure it's plus this time, 0.15 to the t power. There's my model equation. That's the equation I'll use to find all the other stuff. There's my general, there's my model equation. That's the expectation, that you guys write that. Then you go and do the next part. So it says it wants 5 years. Now I have to the 5th power. Go to my calculator. 451 plus 0.15 caret 5. Check my typing there. Check my typing again on the left side. Does it look like what I wrote? Okay. Then I go to look at my answer. Does my answer make sense? Should be more turtles than there were. Do I have more turtles than I started with? Yes. Okay. It's hard to know if I accidentally went crazy. Okay. Because if I typed it way wrong, it's hard to know if that's way too big. That's quite a few more turtles. It's not thousands and thousands more, but it's more. Okay. But we're talking about turtles here. How do I round turtles? I don't have 0.1 of a turtle. Okay. So $905.11 should be about or around or approximately, okay, we talked about using one of these words, 905 turtles. So appropriate rounding and units, okay? And because we are rounding, we use one of these words, about, around, approximately, okay? And then you would go and do the rest of them. We'll get to the other ones later. Somebody's asking to go on to the next page to do one of these. A particular one, Jet? Or Peyton, sorry. I mean, look at 19. It's a pretty tricky problem. Okay? The big thing with all of these was that you're isolating the power, you're isolating the root first. Okay? First thing you have to do is isolate this thing. So if there's anything on the outside of it, that stuff needs to go away first. So you're just using SADMEP to get that done. So if it says plus 12, you're subtracting 12. If it says multiply by 5, you're dividing by 5. So that's the first thing, is isolate that power or that root. Okay. So the first thing I want to do is get rid of that 12. So 5 times x to the 3/4 equals 135. Divide by 5. The order you do this in matters, guys. You gotta do the 12 first and then the 5. That's 27. What I showed you guys to do from there was to rewrite this. Okay? On the last quiz, we did that. It's a skill you guys should have. This is the 4th root of x to the 3rd power. And I told you guys that doing it this way is going to be the easiest way, as far as the way, like where to put the 3. Put it on the outside of the parentheses like that. So this is kind of the key step with these rational exponents, is that rewriting. You're still trying to get x by itself, okay? But I talked to you guys about that idea of you're peeling the onion. Right? On the outside is that cube. To get rid of a cube, we cube root. So I would cube root both sides. You guys can still have your powers chart that we did last test. That cancels that 3. So you're down to the 4th root of x. The cube root of 27 is 3. I get rid of a 4th root by 4th powering, raising both sides to the 4th power. That cancels that. So we get x equals 3 to the 4th is 81. And now we go and check 81. Okay. We always check back in the original equation. So I have to plug back into there. And you do not solve as you're checking. So your job is to simplify that left-hand side. So again, you guys would just type that into your calculator, 81 to the 3/4. I talked to you guys about how to do that. 81 caret parenthesis 3 divided by 4. You have to put that in parentheses, or else it will not give you the right answer. That's 27. So you have 5 times 27 plus 12, which is 135 plus 12, which is 147, which equals 147. Check. Do not solve. Do not move anything across the equal sign when you do that. If you do that, your check is done. You will not get it correct. Anything moves across the equal sign, it's done. Okay? Purely simplifying.